Is my screen visible to all of you? If anyone can respond.
Yes, sir, it is visible.
Yes, sir. Okay, thank you. Somebody is joining. Okay. So those who have joined the meeting, again I am telling you, please give your attendance in the chat box because attendance will be counted. Okay. Anyone please unmute yourself and let me know that whether my slides are visible or not.
Yes, sir, visible.
Okay, thank you. So let us take down the first problem. Let us take down the first problem of friction. So the question is, a wooden block rests on a horizontal plane. Determine the force required to, part A of the problem is pull it and part B of the problem is push it. Assume mass of the block is 5 kg and coefficient of friction, that is mu, is equal to 0.4. So what is given in the problem? A wooden block is resting on a horizontal surface. Horizontal surface is rough in nature, so a frictional force will exist between the two contacting surfaces, and coefficient of friction given in the problem is 0.4. Mass of the block given is 5 kg. What I need to find out? I need to find out the value of force P. First time, when you are pulling the block at an angle of 15 degree. Second time, when you are pushing the block at an angle of 15 degree. Let us assume that P1 is the force required to pull the entire body from at an angle of 15 degree, and P2 is the push force required to give to this body so that the body will move on this horizontal plane. Is the problem clear to you? So what you need to find out? You need to find out the value of P1 and P2. P1 is the pull force and P2 is the push force. Any doubt in the problem? कोई
No,
doubt
sir, no doubt.
है? Okay. If I can get any one answer from electrical, any doubt is there?
No, sir.
Okay, fine. So if I want to find out how much is the pull force acting on this block, so what will be the diagram? The diagram will be like this, that this is a block which is placed on a horizontal surface, and on this block at this point one pull force is applied. Say that force is P1 and it is making an angle of 15 degree with the horizontal. Okay, if this is the condition, then from the diagram it is very much clear that the motion of the block will be in this direction, because if you pull this body at this particular point, body will be moving along positive x direction. So this is the motion of the block. Okay, so in order to find out the value of pull force P1, let us draw the free body diagram of the block. So for this block, weight of the block, that is W, is equal to mg, acting vertically downward from the center of gravity. Okay, and this block is placed on this horizontal surface. So horizontal surface will give a normal reaction to this block in vertically upward direction. Say that normal reaction is nothing but N. Now this force P1 will have two components. because this is your force P1 and it is making an angle theta equal to 15 degree. If this is the case, this is the tail end, this is the head end. So let us draw a right angle triangle. Now if you want to move from tail to a head end, what you need to do? You will go in this direction, you will go in this direction. Then this particular component, it is what? It is nothing but P1 cos 15, and this particular component is what? This is P1 sin 15. That means I can replace this inclined force P1 by two force. One force is this one, and this is nothing but P1 cos 15. P1 cos 15, and another force is this one, which is P1 sine 15. And since the motion of the block is in this direction, so at the point of contact of the block and this horizontal surface, a frictional force will act, and by the law of friction I know that frictional force F is nothing but mu times of N, where mu is coefficient of friction and what is N? N is the normal reaction. So I can write mu times of N. So this is the complete free body diagram for part A of the problem when you are pulling the block. Any doubt in the free body diagram? कोई doubt है किसी को?
No, sir, no doubt.
Okay. If I can get one response from electrical. Any doubt? Hello. Okay, fine. So next is, if I want to find out the value of P1, what I can do? I can use the equations of equilibrium. So if I use summation fx equal to 0, then what I can write? I can write plus P1 cos 15 minus mu n is equal to 0. P1 cos 15 is nothing but 0.965. Mu is given in the problem 0.4. So you will get equation number 1, which is 0.965 P1 minus 0.4 times of n equal to 0. Now if I use summation of Fy equal to 0, then what I can write? I can write plus P1 sin 15 plus n minus mg equal to 0, that is plus p1 sine 15 minus mg plus n equal to 0. P sine 15 is nothing but 0.258, so it will become 0.258 p1 minus m, mass of the block is given to you 5 into g is 9.81, that is acceleration due to gravity, plus n equal to 0. If you solve this expression, you will get equation number 2, which is 0.258 times of P1 plus n is equal to 49.05. Now if you solve equation 1 and equation 2, you are having two unknowns, you will get the value of P1 and n. Since in the problem it has been asked that what will be the value of the force P when you are pulling it, and that force P1 is nothing but 18.36 Newton when you are pulling the object. Any doubt in the first part of the problem?
No, sir, no doubt.
Okay. Very simple problem, nothing we have did, only we have drawn the free body diagram and we are just equating the equations of equilibrium. Same thing we have to do it for the push case also, but for the push case the direction of P1 will change. Now when you are pushing the body, this will be the direction of force P. Say this force P is nothing but P2. Say this force P is nothing but P2. So let us draw the free body diagram of the body once again. So this is the block. On this block, one push force is acting, that is P2, and this force is making an angle of 15 degree with respect to the horizontal. Weight of the block is acting vertically downward from its center of gravity, and this weight is nothing but equal to mg. normal reaction which the surface will give to this block is nothing but your N, and due to this pushing force P, the body will move in this direction. If the body is moving along negative x direction, I know from the law of friction that frictional force will be acting at the point of contact of the two surfaces only in the opposite direction of motion. So this will be the direction of frictional force F, which is equal to mu times of N. Again you can see that this force P2 will have two component. One component is P2 cos 15. This will be your P2 cos 15 at this particular point, and this will be your P2 sin 15 at this particular point. Same thing, this is your P2. Fine, that means this will be your right angle triangle because this is your tail end, this is your head end, this angle is 15 degree. If you want to reach from tail to head end, how you can do? You can go like this and then you can go like this. This value will be your P2 cos 15 and this value will be your P2 sin 15. That means this is your P2 cos 15 and this is your P2 sin 15. Okay, so any doubt so far in the second part of the free body diagram for this problem?
No, sir, no doubt.
Okay, again the same thing we have to do. We have to use the equations of equilibrium. So if I use firstly summation fx equal to 0, what I can write? I can write plus mu n minus P2 cos 15 equal to 0. No other forces are there in x direction. So mu n minus P2 cos 15 equal to 0. Mu is 0.4, so 0.4 times of n minus cos 15 is 0.965 times of P2 equal to 0, which is your equation number 3. Next is I have to use the equations of equilibrium along y direction, that is summation Fy equal to 0. For this case I can write what? I can write plus n minus capital W, which is equal to mg, minus P2 sin 15, plus n minus mg minus P2 sin 15 equal to 0. M given in the problem is 5 kg, so 5 into 9.81. Value of sin 15 is 0.258. So if you substitute all these things in the equation, you will get equation number 4, that is capital N minus 0.258 times of P2 equal to 49.05. Again you are having two equations and two unknowns, so just solve equation number 3 and equation number 4. You will get the value of push force P2 as well as the normal reaction force N, and finally the push force P2 is coming out to be 22.76 Newton. So this is your first problem. Very easy problem. Fine, only we have drawn the free body diagram according to the given conditions of the problem and we have equated the equations of equilibrium. Is it clear? Any doubt in the first problem? कोई डाउट है किसी को?
No, sir, no doubt.
Okay,
No, sir.
fine. Okay. Now let us solve the next problem. Little bit typical problem from the first one. Okay, slowly we will increase the difficulty level. But if you know how to draw the free body diagram, then everything is easy. Okay. So let us solve the second problem. The second problem is a rectangular block of mass capital M rest on a floor. You can see one rectangular block is placed on a horizontal floor. The coefficient of friction between the block and the floor is mu. That means this horizontal floor is rough in nature, so there exists a friction and coefficient of frictional force is mu. What is the highest position for a horizontal force P that would permit to just move the block without tipping? That means what is given in the problem is, on this problem at the upper end of this rectangular block, that means at this particular point, a horizontal force P is applied along negative x direction. What you need to find out? You need to find out how much is the distance d from the floor. You will apply this force P such that this block will move without tipping. By tipping, I mean if the block is moving with tipping, that means what will happen when you apply this force P, the touch at point B between the block and the contacting surface will get disengaged. Then what will happen? This block will have a tendency to rotate about point A. This is known as tipping or toppling. This is known as tipping or toppling. So you have to find out how much distance from the horizontal floor you should apply a force P along negative x direction so that this block will move along negative x axis without tipping or without toppling from point B. Is it clear? Did you understood the problem? Any doubt in understanding the problem? कोई डाउट है किसी को?
No, sir, no doubt.
No, sir.
Fine. So that means you can see that the side, that is the length of the rectangular box which is in contact with the floor surface is given to you, and that length is B. Height of the rectangular box is H, and let us assume that the force, that is I will apply this horizontal force P in negative x direction at a distance small d from the horizontal floor surface to avoid the tipping condition. What I need to find out? I need to find out the value of d. So if I need to find out the value of d, if I find out that what will be the value of d so that tipping takes place, then that much amount of distance d I have to maintain every time in order to keep in mind that this block is moving along negative x direction without toppling. Again I am repeating, if I find out the value of distance d for this particular block for tipping condition, that means that distance is the limiting distance. At most you can apply that much, or you can keep this horizontal force P at that much distance so that your tipping of the block will not take place from point B. Are you getting my point? अगर मैं टिपिंग के लिए निकाल लूं कि अगर ये ब्लॉक टॉपल कर रहा है उस कंडीशन में कितना डिस्टेंस डी में अप्लाई करूंगा कि ये ब्लॉक जो है वो पॉइंट बी से कांटेक्ट हटा देगा, अगर मैं वो निकाल लूं, दैट मींस दैट मच डिस्टेंस इज व्हाट, दैट मच डिस्टेंस इज द लिमिटिंग डिस्टेंस. यू हैव टू अप्लाई दैट मच डिस्टेंस in order to keep the block moving along negative x direction without tipping or without toppling condition. Are you getting my point? Hello.
Yes.
Fine. So for tipping condition or for toppling condition, so let us find out what, or let us draw the free body diagram of this problem. For tipping condition or for toppling condition, remember that this block will not be in touch with this horizontal surface at point B. If this is the condition, then you can see that the block will be in touch with this horizontal surface at point A. Then due to this application of force P, what will happen? This block will have a tendency to rotate about point A. Yes or no? होगा कि नहीं होगा?
Yes, sir.
Fine. So let us draw the free body diagram for this problem when tipping occurs. If that is the case, there will be no normal reaction which the floor will provide to this block at point B. Only normal reaction will be provided by this floor to this block at point A only. Fine. So the free body diagram will be what? It will be, I am having this vertical rectangular box. This is the weight of the box, that is mg, acting from the center of gravity, and that point is nothing but C. At this end I am applying a force P, which is at a distance say D from the horizontal surface, D from the horizontal surface. Fine. And since this is my point B and this is my point A, I am drawing this free body diagram for tipping condition case, then I will not add any kind of reaction at the point of contact B, but reaction will come at the point of contact A. So this horizontal surface will give a normal reaction in vertical direction at point A like this. This is your N, and since due to this force P, body is moving along this direction, so at the contacting point, that is point A, frictional force will act in opposite direction, which is nothing but mu times of N. This is the free body diagram of this problem for tipping condition. Any doubt in the free body diagram? कोई doubt है किसी को?
No, sir, no doubt.
Okay. If I can get any answer from the electrical people? कोई doubt?
Sir.
Hello?
No, sir.
Okay, fine. So, this is your free body diagram, and this distance is B. So, and since the weight of the body mg acting from its center of gravity, so I can say that this much distance is B by 2 and this much distance is B by 2. Now at present condition, the entire body B is rotating about point A, and if this is the case, then moment will come into picture. I have told you in the first module that whenever there will be a rotating condition in any body, moment will come into picture. That means in this problem, somewhere I have to use the moment equation. Somewhere I have to use the moment equation in order to find out what will be the distance D. So first of all, let us write down the equations of equilibrium for this problem, that is summation fx equal to 0 and summation fy equal to 0. When I am doing summation fx equal to 0, so what will be the equation? Equation will be minus p plus mu n equal to 0. No other horizontal forces are present in this problem. So minus p plus mu n equal to 0, which is equation number 1, or I can write more precisely equation number 1 as p is equal to mu n. This is your equation number 1. And if I do summation fy equal to 0, then what I will get? I will get minus mg along negative y direction plus n along positive y direction. No other vertical force is present. So finally my equation will become n is equal to mg. This is your equation number 2. Any doubt in these two equations? Equation 1 and 2, that is p is equal to mu n and n equal to mg. Any doubt? कोई doubt है
No,
किसी
sir.
को? Okay, fine. Next, since I know that the entire body will rotate about point A, so moment will come into picture. So let us take moment in order to find out the value of this distance D. Since the entire body is rotating about point A, so let us take, or let us write down the equilibrium equation of moment about point A. So when I take the summation of moment about point A, what I can get? Moment is what? Moment is force into perpendicular distance. And remember one thing, whenever you are taking moment from any particular point, on that particular point, whatever forces are acting, you will not consider those forces while for moment calculation. For example, I am talking that I will take moment about point A. I can see that from point A, one n normal reaction force n is passing in vertically upward direction, and one frictional force mu n is passing along positive x-axis. But the definition of moment is force into perpendicular distance from the point of application of force. So if you take n and mu n component, there is no perpendicular distance. So I will not consider this force, moment of this force mu n, as well as moment of this force n. Is this part clear? क्या ये पार्ट क्लियर हुआ that mu n and n will not contribute any moment at point A? क्या ये
Yes,
क्लियर
sir.
हुआ?
Clear.
Okay, okay, fine. So let us write down the equations of moment. Moment means I can take this moment, that is mg, moment about point A, into b by 2. Next I need to check the sense, whether it is clockwise or anti-clockwise sense. So mg into b by 2 will create a clockwise moment about point A. Let us assume that the clockwise moment is negative. So I have written minus mg into b by 2. One more moment will come due to this force P, that is this force P into perpendicular distance from the point of application. If this is D, then definitely this distance is also D. So force is P into perpendicular distance from the point of application of the force. So this is the point of application of the force, this is the perpendicular distance. Fine. So it is P into D, and you can see that P into D will create anti-clockwise moment at point A. If I have taken clockwise moment negative, I have to take anti-clockwise moment positive. So finally the equation will become P into D minus mg into b by 2 is equal to 0, which is equation number 3. Any doubt in equation number 3? कोई डाउट है
No, sir. No.
इक्वेशन नंबर 3 में?
No, sir. No.
Okay, fine. So next is I can see that from equation number 1, I can substitute P, how much? I can substitute P by mu times of n, and I can substitute n by mg from equation number 2. Finally P will become mu into n is what? Mg. So in equation number 3, I can substitute the value of P by mu mg. See, mu mg into D is equal to, when you keep this term in this side, minus will become plus, equal to mg into B by 2. Mg cancel. So finally you will get distance small d is what? B divided by 2 times of mu. So you have to keep maximum distance d from the floor to the point of application of this horizontal P to be B by 2 mu, in order to avoid tipping or toppling condition for this block from point B. Is it clear? Any doubt in this
Yes.
problem?
Yes, sir. Clear.
Okay. Anyone from electrical department, if you are having any doubt, you may respond. कोई डाउट है किसी को? Hello, is there any kind of doubt? Electrical, please respond. Okay, if you are not responding, then I will assume that everything is clear. Okay, So what was the difference between the first problem and the second problem? In this second problem, this moment additionally is coming. Why? Because the entire body is rotating about point A. According to the condition of the problem, the entire body is rotating about point A. So like this, you have to handle the problem whenever there is a condition of toppling case or tipping case. Okay. So if the first problem and the second problem is clear to you, now let us go back to the third problem. Little bit more tricky problem. Okay, this is the third problem. So let us read the problem, what the problem is telling to us, and then you have to explain me that what is given in the problem and what we need to find out and how we can find out. Okay, so I'm reading the problem for you. The problem is two blocks of weight W1 equal to 50 Newton and W2 equal to 50 Newton rest on a rough inclined plane and connected by a string as shown in the figure. The coefficient of friction between the inclined plane, I repeat, the coefficient of friction between the inclined plane and W1. That means this is your inclined plane and this is the block W1 is how much? It is nothing but mu1 equal to zero point 0.3. That means coefficient of friction at the contacting surface at this point. Mu1 is 0.3 and mu2 is for the contacting surface of the block W2 and the inclined plane. That means for this particular surface mu2 given is 0.2. Okay, find the inclination of the plane for which slipping will impede. What you need to find out? You need to find out the inclination of the plane for which slipping will impede. So can anyone tell me that what we need to find out in the problem? What we need to find out in the problem? If you have understood the problem, please let me know that what we need to find out in this problem.
Sir, alpha.
I need to find out the value of angle alpha, correct? But for which condition I need to find out the value of alpha? That is also given in the problem. Read carefully and tell me. For which condition I can find out the value of alpha? Because this alpha can be anything. The alpha will start from 0
Sir,
degree.
to reduce sleeping. To reduce sleeping.
Alpha will start from 0 degree and it will end at 180 degree. When this inclined plane will become straight somewhat like this, then your alpha will end. That means alpha can vary from 0 degree to 180 degree. But for which condition of inclined plane I need to find out the value of alpha? It is given in the problem, if you read the last line, that you need to find out the inclination of the plane, which is nothing but alpha, for which the slipping will impede. By this term is known as impending motion. Impending motion means you have to find out that value of angle alpha at which the motion of the block will start, and you need to find out that value of angle alpha at which the entire system will start to move down the inclined plane. Yes or no? Is it clear? Did you understood the problem?
Yes, sir.
That means alpha is nothing but angle of repose. If I relate physically with the concept of angle of repose, what is angle of repose? Angle of repose is that particular angle of an inclined plane. If you keep any body on that inclined plane, Then for angle of repose to happen, if you apply the value of alpha equal to 45 degree, then at 45 degree motion of the block will start. That means the block will start to slide down the inclined plane. That means that 45 degree angle is nothing but angle of repose. So here in this problem, ultimately I need to find out what? I need to find out angle of repose. That means what will be the value of angle alpha for which the motion of the system will start. Yes or no? Is it clear? Any doubt?
No, sir, no.
Okay, so then you please let me know that what will be the direction of the motion, whether the motion will be in this direction or whether the motion will be in this direction along the inclined plane. Downward direction or upward direction motion?
Downward direction.
Yes, the block will move down the inclined plane. So it is not necessary that every time in the problem direction of motion of the problem will be given to you. You have to read the problem, you have to see the diagram, accordingly you have to understand that what is the direction of motion. Okay, so in order to find out the value of angle alpha, what I will do? Separately, I will draw the free body diagram of the first block. I will write down the equations of equilibrium. Separately, I will draw the free body diagram of the second block. I will write down the equations of equilibrium. Then I will do some substitution kind of thing, and ultimately I will get the value of alpha. Is the process clear?
Yes, sir.
Okay, okay. Anyone from electrical? If you can respond whether you understood the problem or not.
Yes, sir.
Okay, 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 fine. So first of all, let us draw the free body diagram of the first block. Okay, so this is my first block. Fine. And since the block is moving down the inclined plane, then for this case, this will be your x-axis and this will be your y-axis. Now, the motion is not occurring along this normal x, which we take it as horizontal, and normal y, which we take it as vertical. Now, the motion is occurring along the inclined plane. So this direction, the direction of the inclined plane will be my x-axis and this direction will be my y-axis. I hope this is clear to you, the directions. Is there any doubt in the direction?
No, sir, no doubt.
Okay, fine. So next is, so let us draw the free body diagram. Weight of the first block W1 acting vertically downward from the center of gravity. Okay, the block is in contact with this inclined plane, so inclined plane will give a normal reaction to this block. Say that normal reaction is nothing but n1 in this direction. If this angle is alpha and if this is your normal reaction n1, definitely I know by geometry that this angle will be also alpha. That means this angle is alpha. If this angle is alpha and this is W1, then this W1 will have two component. One component is cos and another component is sine. Since this angle is alpha, so this value will be, this component is your W1 cos alpha and this component is your W1 sine alpha. Fine. And since the motion of the first block is in this direction, frictional force between the contacting point will act in the opposite direction to the motion of the block. That is, frictional force will be mu1. Mu1 is the coefficient of friction between the first block and the inclined surface into normal reaction in 1. as well as you can see that the first block is connected with the second block by a string. So first block will exert some tension on this string, and that tension is nothing but tension T acting in this direction. This is your tension T. So this is the overall free body diagram of the first block. If you are having any kind of doubt in the free body diagram, you may ask. Are you having any kind of doubt in the free body diagram of the first block? कोई doubt है किसी को?
No, sir, no doubt.
Okay, electrical people, please respond.
Sir, can you explain the tension direction?
Direction of tension. Okay, this is the chord with which, or this is the common string with which both the blocks are connected. Fine. If if both the block, if you are holding it tight, then what will happen? This W2 block will give a tension to this string for W1 block in this direction, and W1 block will give or will exert tension on this chord for this W2 block in this direction. So for W1 block, direction of tension is this one, and for W2 block, direction of tension will be this one. Any doubt? If you
No.
take the direction opposite also, not a problem. Ultimately, your answer will come out to be negative. If your answer of tension T is coming out to be negative, that means you have taken the wrong direction. Direction will be in opposite nature. Okay. Now it is clear? कोई doubt?
No, sir, no
Okay.
Okay.
doubt.
So for this first block, let us write down the equations of equilibrium, that is summation fx equal to 0 and summation fy equal to 0. Remember, for this case, this is my x direction and this is my y direction. So if I write summation fx equal to 0, what I can write? I can write plus mu1 n1 minus W1 sin alpha minus T equal to 0. See, plus mu1 n1 minus W1 sin alpha minus T equal to 0, which is equation number 1. Any doubt in summation fx equal to 0? कोई doubt है किसी को?
No, sir.
Now, if I write summation fy equal to 0, what I can write? I can write plus n1 minus W1 cos alpha equal to 0. No other forces are present. So finally I can write N1 is equal to W1 cos alpha, which is equation number 2. Is it clear? Summation Fy equal to 0. Any doubt?
No, sir.
Okay. Similarly, for the second block, again let us draw the free body diagram. So this is my second block. This is my second block. Weight of the block W2 acting vertically downward from the center of gravity of the block. Inclined plane will give a normal reaction to this block in this direction. This is N2. If this angle is alpha, definitely this angle will also be alpha. If this angle is alpha, then this W2 will have two component. One is W2 cos alpha, another one is W2 sin alpha. This component will be your W2 cos alpha, and this component will be your W2 sin alpha. Now for the second block, this is the direction of tension present in the string, that is T. and motion of the second block is in this direction. So frictional force between the two contacting surfaces will be in opposite direction. This is the frictional force F. 2 is nothing but mu 2. Mu 2 is the coefficient of friction between the second block and the inclined plane into N2. So this is the final free body diagram for the second block. Any doubt? Any doubt so far in the free body diagram of the second block?
No, sir, no doubt.
Okay. Electrical people, is it clear?
Yes, sir.
Okay, fine. Again, for the second block also, I will do the same thing. I will write down the equations of equilibrium. Fine. So, firstly, let us write summation fx equal to 0. So, if I write summation fx equal to 0, what I can write? I can write plus t plus mu 2 n2 minus w2 sine alpha equal to 0. See? Mu 2 into minus w2 sine alpha plus t equal to 0. Let it be third equation. And for the second block, if I write summation fy equal to 0, what I can write? Plus n2 minus w2 cos alpha equal to 0. No other force is present. So finally I can write n2 equal to w2 cos alpha, which is equation 3 and equation number 4. Any doubt in equation 3 and 4? कोई डाउट है किसी
No,
को
sir, no doubt. No,
इक्वेशन 3 and 4 में
sir, no doubt.
fine okay so we have so far we are having four equations. Equation 1 and 2 we are getting from the free body diagram of the first block, and equation 3 and equation 4 we are getting from the free body diagram of the second block. But the question is, I have to find out the value of alpha. So how we can find out the value of alpha? For that, what I am doing is, you can use any kind of trick, whatever you feel the best or with which you can get the answer. Fine. What I found is that if I add equation 1 and equation 3, if you add equation 1 with equation 3, so what will be the case? It will be mu1 n1 minus w1 sine alpha minus t plus the third equation. Plus the third equation is plus mu2 n2 plus minus becomes minus w2 sine alpha and plus becomes plus t equal to 0. So if you see that this minus t and this plus t will get cancel if you add equation 1 and 3. So the final resulting equation becomes mu1 n1 plus mu2 n2 minus w1 sine alpha minus w2 sine alpha equal to 0, which is equation number 5. Is it clear? When you add equation 1 with equation 3, minus t from equation number 1 and plus t from equation number 3 will cancel each other. Okay? Any doubt so far? Any doubt so far?
No, sir, no doubt.
Fine. Okay. So if you see equation number 5, if you see equation number 5, here I am getting mu1 and 1. Here I am getting mu2 and 2. But I need to find out what? I need to find out the value of alpha. So if you observe equation number 5 carefully, here I am having alpha, here I am having alpha. But in this place as well as in this place of this equation number 5, I don't have alpha. So somehow, if in place of say in this part, if somehow I can replace this part by alpha, somehow I can replace this part by alpha, then the entire equation number 5 will be in terms of alpha and easily I can find out the value of alpha. Yes or no? Yes or no?
Yes, sir.
Fine. So for that we are having equation. If you see equation number 2, I have N1 is equal to W1 cos alpha. So in place of N1, if I replace W1 cos alpha, and from equation number 4, in place of N2, if I replace W2 cos alpha, then you can see that your entire equation number 5 will be in terms of alpha, and then you can easily find out the value of alpha. Fine. So let us substitute the value of n1 and n2 from equation number 2 and 4. So in place of n1 I am writing w1 cos alpha. Then this particular expression becomes mu1 w1 cos alpha. And in place of n2 I am writing w2 cos alpha. Then this particular expression becomes mu2 w2 cos alpha minus w1 sin alpha, as it is I am keeping, minus w2 sin alpha equal to 0, as it is I am keeping. So what we can do, from this particular expression, I can take cos alpha common. If you take cos alpha common, the resulting equation becomes mu1 w1 plus mu2 w2, and this particular term I can take it on the right hand side. If you take it, your equation will be w1 sin alpha plus w2 sin alpha. You can take sin alpha common. Finally it will become w1 plus w2 into sin alpha. Now if I take sin by cos, I know that sine by cos is tan alpha. So tan alpha is equal to mu1 w1 plus mu2 w2 divided by w1 plus w2. Fine. So alpha will be what? Alpha will be tan inverse of mu1 w1 plus mu2 w2 divided by w1 plus w2. Mu1 is given in the problem 0.3, mu2 is given in the problem 0.2, w1 and w2 equal to 50 Newton. So you substitute all the values in this particular equation, take the inverse of tan, you will get the value of angle alpha, and that alpha is coming out to be 14.036 degree. So if you apply, or if you keep the inclined plane at an angle of 14.036 degree from the horizontal, then the system which is present on the inclined plane, it will start to move down the inclined plane. So this is the problem. So any doubt in this problem? कोई डाउट है किसी को?
No, sir, no doubt.
Okay. Electrical people, please respond whether the problem is clear or not.
Yes, sir. Clear.
Okay, fine. So see here I will make you solve each and every variety. Fine, one problem I will take and I will solve the variety. But for your practice, you have to solve the problems from the book, both the solved as well as unsolved problems, because in exam you will get a new problem. So if you do the practice well, then you can understand that what is given in the problem and how to approach. So just practice. Fine. Okay. So we will do one more problem, and after that problem we will end the class. Okay. So let us solve that problem, that last problem, and it is a good problem. You will come to know many things from that problem. Okay, let me erase everything and let me close this slide. It is not there in this slide. So just close this slide. Okay. Yes, this problem. Okay. So is the slide visible to you? Can you see the problem?
Yes, sir. Fine.
Okay. So what is this problem is? The problem is the determine the frictional force developed on the block as shown in the figure when force P is equal to 40 Newton. Second case, when the same force P is 80 Newton. Given that the coefficient of static and kinetic friction between the block and the floor is mu s, that is coefficient of static friction is 0.3, and mu k, coefficient of dynamic friction is 0.25, and also find the value of P when the block is about to move. That means what is given in the problem? On a horizontal surface, a block is kept. Weight of the block is 100 Newton, which is acting vertically downward from the center of the gravity given in the diagram. On this block, a force P is applied, and this force P is a push kind of force, and it is applied at an angle of 30° with respect to horizontal. When the value of P is 40 Newton, what is the value of frictional force that I need to find out? When the value of P is 80 Newton, what is the value of frictional force that you need to find out? In the problem, the coefficient of static and kinetic friction is given to you, and lastly you need to find out the value of force P when the block is about to move. About to move means impending condition. Fine. So did you understood the problem? Any doubt?
No, sir. No doubt.
Okay, so very easily we can solve this problem, yes or no? Hello.
Yes,
Very
sir.
easily we can solve this problem. Okay, okay. But you can see that in this problem, two coefficient of friction value is given to you. One is a coefficient of static friction value is given to you 0.3, and another one is coefficient of kinetic friction value is given to you 0.25, and I know that frictional force is what? It is mu times of normal reaction. So when you draw the free body diagram of this body, what will be the free body diagram? Weight is acting vertically downward, fine, and this horizontal surface will give you a normal reaction on this particular body in vertically upward direction, and this is the weight 100 Newton acting vertically downward. This force P will have two component. One component, this component will be your cos component, which is P cos 30, and another component will be your sine component, which is P sine 30. Now due to this push force, body is moving in this direction. If the movement of the body is in this direction, then the frictional force at the point of contact will be in opposite direction. Let us assume that this is the direction of frictional force. Frictional force F is equal to mu times of N. Okay, but the problem is which value of mu I will take, because in the given problem coefficient of static friction value is also given to you, coefficient of dynamic friction value is also given to you. So can you tell me that while solving the problem which value of mu you will take and then you will solve the problem? बोलो कौन सा म्यू वैल्यू लूंगा प्रॉब्लम को
Sir,
सॉल्व
to find a frictional force, we will use mu s because it's a static friction.
बट बॉडी तो मूव हो रहा है ड्यू टू दिस फोर्स पी बॉडी इज मूविंग अलोंग पॉजिटिव एक्स डायरेक्शन mu k is what? Mu k is coefficient of kinetic friction or dynamic friction. When the body is in moving condition, at that time we have to go for the dynamic coefficient of friction value, and when the body is in static condition, during that time I have to go for coefficient of static friction value. So which friction value will I use? Coefficient of friction value. Whether I will use mu as value or I will use mu k value. यहाँ पे तो दिक्कत है।
Sir, sir, when the block is about to move, then we will use mu s,
तो
I
वो
think.
कैसे पता चलेगा आपको कि when the block is about to move? तो निकालना पड़ेगा, तो निकालना पड़ेगा ना, तभी तो मुझे पता चलेगा। सी, अभी तक मैंने जो भी प्रॉब्लम सॉल्व किया, वॉट एवर प्रॉब्लम वी हैव सॉल्व्ड, in the problem only one mu value is given to you, but in this problem two mu values are given to you. One is coefficient of static friction value is given, another one is coefficient of dynamic friction value is given. So I don't know that which mu value I will substitute over here to solve the problem. In that case, first of all, what I need to do, first of all I need to understand that what is happening in the problem, whether the body is completely in dynamic motion, whether the body is completely in the condition of static motion, that means no movement, that means body is not at all moving, or the third condition, that whether the body is in limiting condition or not. Limiting condition means about to move or impending motion, yes or no, then only I can solve this problem. Yes or no? Hello.
Yes, sir.
Yes, sir.
Fine. So in this problem, so always remember, if you see, if in any problem mu s is given to you, mu k is given to you, blindly you cannot use any value, you solve the problem, it will be wrong. If mu s and mu k is given to you, that means you have to see what is happening in the problem, whether the body is in dynamic equilibrium, or whether the body is in static equilibrium, or whether it is in limiting equilibrium. Accordingly the value of mu will change, accordingly your answer of frictional force will change. Fine. So we have drawn the free body diagram, fine. Now let us solve for the first case, when the value of P is 40 Newton. That means this horizontal component will be 40 cos 30 and this vertical component will be 40 sin 30. So if I write the equations of equilibrium, that is summation fx equal to 0, what I can write? I can write plus P cos 30 minus mu times of n is equal to 0. See, I can write yes, that is plus P cos 30 minus frictional force F, which is mu times of n, is equal to 0. Fine. Or I can write F is equal to P cos 30. What is P? P is your 40 in the first case. So I got 40 cos 30, which is coming out to be 34.64 Newton. So frictional force is 34.64 Newton. But whether this frictional force is correct or not, I don't know, because I have not substituted the value of mu. I don't know that whether the frictional force which I have got, this is a static frictional force value, or this is a limiting frictional force value, or this is a dynamic frictional force value. I don't know, but I know that this is a frictional force value. That means I don't know the motion of the body, whether it is in static motion or whether it is in dynamic motion or in limiting motion. So I have to find out what is happening in the body, whether due to this force P equal to 40 Newton, whether the body will move or it won't move. Accordingly, we will see that whether the frictional force which I have calculated, it is correct or not. So for that, what I do, I know that frictional force F is mu into n. Mu I don't know. I don't know so far mu. N I can calculate. How I can calculate n? If I use summation Fy equal to 0. If you use summation Fy equal to 0, I can write plus n minus 1000 Newton minus P sin 30 equal to 0. So n minus 1000 minus p is nothing but 40. 40 sine 30 equal to 0. If you solve this equation, you will get the value of n as 120 Newton. You will get the value of n as 120 Newton. Now, if you remember when I was discussing the different types of friction, that is static friction, limiting friction, and dynamic friction, during that time I have drawn one graph, that is a graph between frictional force F and applied force P on the body. That graph was like this, somewhat like this. Fine. And I have told you that during in the leftmost part, the body will not move. In the leftmost part, the body will not move. That means the value so the relationship between frictional force P and the applied force P will be a straight line. No motion will take place in this condition. At this condition, this is a limiting condition. This is a limiting condition. At this condition, body will about to move. And after this condition, that means if I talk about this condition, body will be in motion completely. Body will be in motion completely. So for this particular case, when P is 40 Newton, I have to find out whether it is the condition of static equilibrium, or it is the condition of limiting equilibrium, or it is the condition of dynamic equilibrium. I can see that this is the value of maximum frictional force F max. This is the value of maximum frictional force F max. From the diagram I can see that if my frictional force F, if this F is equal to F max, then only the limiting equilibrium condition will exist. Yes or no? Please verify me whether I am correct or not. If the
Yes, sir.
applied frictional force is equal to F max, from the diagram I can say that limiting frictional force exists. So if limiting frictional force exists, I have to find out the value of F max first. What is F max? For limiting condition, can you tell me which coefficient of friction value I will take? Will I take mu k or will I take mu s in calculation? Because I know that F max will be mu into n. But mu will be what? Whether it will be mu s or whether it will be mu k. For limiting condition?
Sir, mu s.
Mu s, because body is about to move. It has not moved. It will be about to move. So the value of mu will be mu s. So I can write F max is equal to mu s into n. N already we have calculated, that is 120 Newton into mu s. Mu s given in the problem 0.3. How much I am getting F max? I am getting F max as 36 Newton. Now let us compare this F max with my F value. My frictional force value is 34.64 Newton and the F max limiting frictional force value is 36 Newton. That means I can say that F is less than F max. That means the frictional force due to this load P is less than the limiting frictional force. If this is the case, will the body move or the body will not move? If F is less than F max, whether the body will move,
Not
yes
mu.
or no? Hello?
Not mu.
The body will not move because the maximum frictional force is more and the frictional force which we are getting from this value of force P equal to 40 Newton, that is less. That means there will be no motion in the body. If there will be no motion in the body will be in static equilibrium condition, and for static equilibrium condition, frictional force F is nothing but mu s into n. That means the value of F, whatever I have calculated, that is the correct value. So the corrected value of frictional force F is nothing but 34.64 Newton. So this is the first part of the problem. बोलो समझ में आया कि नहीं आया? कोई
Yes,
डाउट है
sir.
किसी को?
No, sir, no doubt.
ओके, इलेक्ट्रिकल पीपल प्लीज रिस्पॉन्ड. क्या कोई डाउट है किसी को?
Sir.
हेलो.
No, sir.
Fine. Okay. So see, in the same manner, let us solve the second part of the problem. Second part of the problem is when P is 80 Newton. When P is 80 Newton, then what is the value of frictional force? Same thing. So when P is 80 Newton, fine. So let us find out first summation Fx equal to 0. Summation Fx equal to 0 will be plus P cos 30 minus mu n is equal to 0, but I don't know what will be the value of mu, but I know that mu n is nothing but f, so I can write plus p cos 30 minus f is equal to 0, plus p cos 30 minus f is equal to 0. F is how much? P cos 30. P for this time P is 80 Newton. So 80 cos 30 and F is coming out to be 69.28 Newton. The frictional force which I am getting 69.28 Newton. Whether it is correct frictional force or not, I don't know. I have to check. I have to check that whether this force value is equal to the limiting frictional force value or is less than the limiting frictional force value or it is greater than the limiting frictional force value. Fine. So in order to find out that frictional force value, I know that frictional force is what? Mu into n. So I need to find out the value of normal reaction first. For that, I have to use the equations of equilibrium along y-axis. So I can write that plus n minus 100 minus p sine 30 is equal to 0. See, plus n minus 100 minus p sine 30 equal to 0. In this case, p is 80 Newton. You will get the value of normal reaction n as 140 Newton. Fine. So now let us find out that for limiting equilibrium condition, that means when the body is about to move, F will be equal to F max. F max is what? F max for limiting condition, F max is mu into n, and mu will be what? Mu is nothing but static friction because the motion has not started yet. It is about to start. So I have to take the static coefficient of friction value. So F max is mu s into n. N already we have calculated, that is 140 Newton into mu s. Mu s is 0.3. So I am getting F max as 42 Newton. Now compare this F max value with F value. F value is more. F max value is less. That means F is greater than F max. If F is greater than F max, you tell me whether the body will be in motion or the body is about to move or the body is in static condition. Tell me which case will apply. We will apply which case? Hello.
The body will be in motion.
Yes, because when the frictional force which you have got by taking force P equal to 80 Newton, if it is greater than the maximum frictional force, that means body will be in motion. So when body will be in motion, you have to take the coefficient of kinetic friction value or coefficient of dynamic friction value. That means the frictional force earlier which we have calculated, that is F is equal to 69.28 Newton. It is the wrong frictional force. The corrected frictional force will be F is equal to mu k into n. Mu k given in the problem is 0.25 into n is normal reaction, which is nothing but 140 Newton, and finally I will get the value of the corrected frictional force F is 35 Newton. This is the second part of the problem. That means when you will apply a force P of 80 Newton, then the body will be in motion. During the motion condition, the coefficient of the frictional force acting at the point of contact of the body will be 35 Newton. Any doubt in the second part of the problem? क्या कोई doubt है किसी को?
No,
कोई
sir,
doubt
no.
है किसी को?
No doubt, sir.
Okay, okay, fine. The third part of the problem. What is the third part of the problem? Third part of the problem is also find the value of P when the block is about to move. So this is which condition? This is static condition, dynamic condition or limiting condition. Third part is which condition? Which condition is?
Lim-
Yes?
Limiting condition.
Yes. In the problem it is given to you that you have to find the value of P when the block is about to move. Fine. So when the block is about to move, that means limiting condition. So for that limiting condition, the value of frictional force F, in that value you have to take which coefficient of friction value? You have to take mu S, that is coefficient of static friction value. Fine. So for third case, again if I use the equations of equilibrium, I can write that summation fx equal to 0 is what? Plus p cos 30 minus mu s into n is equal to 0. See? Plus p cos 30, fine, plus p cos 30 minus mu s into n is equal to 0, or mu s into, that means for limiting condition f is nothing but f max, so I can write p cos 30 minus f max equal to 0. P cos 30 minus f max is mu s into n. P I need to find out, N I don't know, so I have to use the equations of equilibrium along y axis. So for y axis, when I will use, I can write plus N minus P sine 30 minus 100 equal to 0. That is, I can write N is equal to 100 plus P sine 30, which is equation number 1. So in this expression of fx, that is p cos 30 minus mu s into n is equal to 0, in place of n I can substitute this value, that is 100 plus p sin 30. When you substitute, you will get p cos 30 minus mu s is 0.3 into what is n from equation number 1, 100 plus p sin 30 equal to 0. Or we can write p cos 30 minus 100 into 0.3 is 30 minus plus minus p sin 30 into 0.3. So if you solve this expression, finally you will get the value of applied force P is how much? It is 41.89 Newton. That means on this particular block, that means on this particular block, when you apply force P equal to 41.89 Newton, then the limiting condition will exist, then the body will start to move, or the condition of impending motion will exist. This is the third part of the problem. Any doubt?
No,
Any
sir,
doubt
no, no.
about the third part? So did you got the problem? That so far today we have discussed 4 problems. All the 4 problems are of different variety. So I hope it might be clear to you that how to solve the friction problems, how to approach these problems. Okay, fine. Okay.
Yes, sir.
Yes,
So
sir.
with this, so I am ending today's lecture over here. We will, if I will take the extra class, I will notify you in your Google Classroom, or else we will meet on Wednesday. Fine. So mechanical people, you please stay in the meeting. Electrical people can leave the meeting. If you have given your attendance, you can leave the meeting. Thank you. Okay, Shubho is there, Chandrakant is there, and Shomodeep is there. Okay, so why I have told you to be there in the meeting is that I'm telling you your midterm marks because I cannot publish the results in your WhatsApp group. So if you want, then I can tell you your marks, and you can tell your friends also that if they want to know the marks, they can ping me in WhatsApp. I will tell them that their marks. So should I tell you your marks?
Sir, what is the highest?
Let me tell you. Let me tell you the marks. Just wait for a minute. हाईएस्ट थोड़ा कम ही है क्योंकि एक तो किसी ने ही पूरा पेपर नहीं किया है और ठीक है कोई बात नहीं तो ये हो जाएगा अगर आपको इस टाइम अगर आपको मिड टर्म में आउट ऑफ 70 इफ यू आर गेटिंग say 40 then you are doing good in this subject then you can expect in end sem at least more than 50 marks the only just wait for a minute